So let's understand how translation of address would work. We all know till now that processor will always provide address in terms of logical. We also know that the page needs to be referred at a particular address in a memory. Now let's see how things would work. What you are seeing is called as a page mapping phenomena. The page mapping phenomena works in a very simple and a direct manner. Each one has a page number. Each page has a page number. Let's say page 1, 2, 3, 4 in current case. And where we are storing. Consider this is stored from 0 to 100. That means only 0 to 100 was the OS. Now I am considering each offset of 200. That is 100, sorry. Each offset of 100. So let's see how the system would go. The page number would refer which page number your data is in. Offset would refer is within the page where your data is. And after combining frame number along with the offset, we will have physical address. I'll take a practical example to make you clear what we are talking about. Consider we have page 2. In that we have 10th line, which is some add function. Mind you, we have page 2 in that 10th line is adding some function. Now coming back to this, let's say page 1 is at 100, page 2 is at 200, page 3 is at 300, page 4 is at 400. Now see how mapping would done. When the CPU gives the address, it would provide two details. Number 1, page number, and number 2, offset. Now from the offset and page number, it is clear what page we are trying to. So in our current case, it is page number 2. The moment page number is clear, frame number is clear. Again going with it. As we said earlier, we have page number 2 offset 10. Let's try to understand. For page number 2, we have selected frame number 2, which is at 300. So this would give me 300. Offset gets carried away, which is 10. So the ideology behind this is at 310 you'll find that data. So this is how you can convert. So now in the memory, I know from 300 I am starting that page. So that particular page exists. Let's call it page 2. It starts from the 300 part. And now I know in page 2 310 would be that add function. So this is how paging takes place and addressing of paging takes place. Let's try to see advantages of paging now. Paging does remove external fragmentation, but still suffers from internal fragmentation. Just slightly moving it. But still suffers from internal fragmentation. That is because of one simple thing, because we can have a page even smaller than the given frame. Consider the frame is of 100 and the last page which is left would be of 10. This would produce a fragmentation of 90. But it exists, but much lesser, because most of the last pages or part of the data, last part of the data would create pages which are smaller than the frame and the page size. Second thing, page is simple to implement and assumed to be more efficient memory management. Yes, because of main reason is pages can anytime taken out when they no longer needed, can be put in when they are more needed. So it is obviously more efficient. Due to equal size pages and frames, tracking becomes easy. This is very important because in earlier cases of the continuous memory allocation, variable size or dynamic, we used to assign space, resize space and give. Whereas in paging, since frame size is very clear, page size is equivalent to the frame size, it is not going to be much issue. Just one need to search for an empty frame where page can be added. Another disadvantage is page requires extra memory. Why this is good disadvantage? This will be mainly disadvantage if you have a small memory. So that's it. That's what paging system is about. We clearly said that paging works in a concept of dividing data into pages and dividing main memory into frames and then storing pages in necessary frames or at necessary frames. So that's it in the video, guys. Thanks for